Hello and welcome to the lecture series on Principle of Electrical Engineering. In today's lecture, we are going to start Unit 1, that is Electric Circuits. In this unit, we are going to cover the following topics. First topic is single phase AC circuit. Dear students, before starting this topic, let us have a very quick overview of some basic concepts related to electrical engineering. If we talk about electrical engineering, basically we are talking about dealing with electric charge or current, or you can say that current we are talking about dealing with the flow of electric charge. So let us have a look on what is basically an electric charge is. In very concise way, if we define electric charge, we can say that electric charge is a physical property of a particle which is very small, that is smaller than the size of an atom, that is a particle which is subatomic in nature. And if we talk about subatomic particles, we are basically talking about electrons and protons. So one can say that electric charge can be defined as the physical property of electrons and protons. The SI unit of electric charge is coulomb, which is symbolically represented by capital letter C. This unit is basically named after the scientist Charles Coulomb. Coulomb is a very large unit. You can visualize this by looking at the charge on one electron. If you look at the charge on one electron, you know that it is 1.6 into 10 raised to the power minus 19 coulomb. Now just visualize that this small charge is on one electron. Now at this moment I am giving you a practice exercise. Now try to calculate the number of electrons required in order to constitute a 1 coulomb charge. Once you know the number of electrons, then try to calculate the mass of these electrons. Once you calculate the mass of these electrons, you will find that 1 coulomb charge is a very large quantity. Now dear students, another important quantity associated with electric charge is law of conservation of charge. According to the law of conservation of charge, charge can neither be created nor be destroyed, or you can say that it can only be transferred from one body to another, and the net charge quantity is always conserved in the universe. This law of conservation of charge was first proposed in 1746, and it took almost 100 years to prove this law of conservation of charge. This proof was given by Michael Faraday in 1843. Now let us have a look on another important concept, that is electric current. As I told you earlier, electric current means that the flow of electric charge. If we try to define electric current in a very concise manner, one can say that movement or transfer of electric charge through an area is known as electric current. Let us have a look on instantaneous current. Instantaneous current is represented by a small letter I and is equals to the small amount of charge passing through an area in a small amount of time. In case of electric circuits, electric current we are talking about, it is usually carried by electrons, although the electric current can also be carried by ions, but it cannot be carried by the atoms. In case of electric circuit, electric charge is usually carried by electrons. So we can say that while dealing with electric circuit, electric current we mean that the flow of electrons, that is the flow of electric charge. Now let us have a look on the SI unit of electric current. The SI unit of electric current is ampere, and it is symbolically represented by capital letter A. If we want to define 1 ampere, then we can say that when a 1 coulomb charge passing through 1 meter square area in 1 second time, then we can say that the electric current is equals to 1 ampere. Just like the unit coulomb that is named by its inventor, ampere is also named after the French scientist Andrew Ampere. We just discussed about electric current and instantaneous current. Now let us have a look on conventional current. Conventional current we usually use while dealing with electric circuit analysis. We use conventional direction, that is the direction of that conventional current. So it's very important to discuss what is basically a conventional current is. Conventional current is the current which is due to the positive charge movement, or you can say that it is the current which is in the direction of electric field, and this is the current we are going to use throughout this course. So by the positive charge we do not mean the hole present in the semiconductor, because we are talking about the metal while dealing with the electric circuit. Now on the other hand, you were thinking that in a circuit, if there is no hole, there are electrons present in the circuit and the charge on an electron is negative, and we know that the flow of current is due to the flow of electrons. Actually, we consider that conventional current is due to the flow of positive charge, which means that the direction of conventional current is opposite to the direction of flow of electrons. Basically, flow of electrons, we say that this is the natural current. Electron current is basically a natural current, and the movement of natural current is in the direction of the movement of negative charge, that is electron movement. So don't be confused. You should remember that if we talk about the conventional current, we mean that the current which is due to the positive charge movement, that is opposite to the movement of the electron in the circuit. And if we are talking about the natural current, we are basically talking about the electron current. We just discussed about conventional current and natural current. From this discussion, one can say that the current has magnitude as well as the current has direction. Now let us have a look on the current as a scalar or a vector quantity. We know that scalar quantities are those quantities which have magnitude but no direction, whereas vector quantities are those quantities which have magnitude and direction, as well as they have to follow vector laws, that is vector addition, vector subtraction. So let us have a look on current. If we look at current, we know that the current has magnitude, also the current has direction. But if we observe that whether the current is following the vector's law, if current follows the vector's law, then only we can say that the current is a vector quantity. Otherwise the current is not a vector quantity, it will consider as a scalar quantity. You know that at any junction, how we are going to add the current? We usually algebraically sum all the current entering and leaving the junction. So from this you can say that in case of current, it does not satisfy vector's law of addition. If you similarly check other vectors law, you will find that the current does not satisfy vector laws. Therefore the current is not considered as a vector quantity, so the current is basically a scalar quantity. Another important term used in dealing electric circuit is electric potential. Let us have a look on electric potential. Electric potential, we can say that is the work done in moving a charge from the reference point to any specific point in the electric field, and we know that the work done will get stored in the form of electric potential energy. Therefore electric potential is also called as the electric potential energy per unit charge. Dear students, here it is important to note that whenever the electric potential at a point is defined in an electric field, it means that This potential is basically calculated with respect to a reference point. Now let us have a look on the SI unit of electric potential energy. As you know that the SI unit of electric potential energy is joule. Electric potential, as I just told you, is equal to the electric potential energy per unit charge, that is electric potential energy divided by charge. Therefore, if we look at the unit of electric potential, that is electric potential difference, then we can say that the electric potential difference will be the same as electric potential, that is joule per coulomb. We usually call joule per coulomb as the unit of electric potential difference, and in SI unit we use the term voltage for expressing electric potential difference. See, right now I am using the term electric potential difference instead of electric potential. Why? Because as I told you earlier, that is an important point which you have to remember throughout the course, that whenever we say electric potential at a given point, it means that it is calculated with respect to a reference point. It means that it is basically a potential difference between the reference point and a given point. So electric potential difference, the SI unit is voltage, which is in short written as volt, and volt symbolically represented by a capital letter V. This unit is named after the Italian scientist Alessandro Volta. We just discussed about electric current, then we discussed electric potential. Now we are going to discuss another important quantity, that is electric power. Electric power can be defined as electrical potential energy transferred per unit time by an electric circuit on electrical element. So in simple word we can say that electrical power is the time rate of change of electrical energy. So if we talk about the SI unit of electric power, the SI unit of electric power is watt, and symbolically it is represented by W. Electric power is basically, if we talk about the definition of electric power, we can say that the electric power can be defined as the amount of electrical energy transferred per unit time by an electric circuit on the electrical element. Or in simple word we can say that electric power is the time rate of change of electrical energy. The SI unit of electric power is watt, which is symbolically represented by W. So by the definition, as we can see that electric power is the time rate of change of electrical energy. And if you look at the electrical energy, then we know that electrical energy is charge into voltage, that is QV. So we can say that electrical power is nothing but QV per unit time, that is QV upon time. And if we look at the expression of it, you will find that Q into V upon time is nothing but Q upon time into V, and Q per unit time is basically defined as the current. So the electrical power can be expressed as current into voltage, that is I into V. So dear students, let us summarize what we learned today. In today's lecture we just discussed about the basic concepts of electrical engineering. In basic concepts of electrical engine, we start with electric charge, then we discuss about electric current, then we discuss about electric potential, and then we just discuss about electric power. And during the lecture I just give you a home exercise problem. In that problem what you have to do is you have to calculate the number of electrons required to form 1 coulomb of charge, and you have to calculate the weight of those electrons. This is all about today's lecture. In the next lecture we will discuss about the single phase AC circuit.